Hi students, in this video we are going to discuss some numericals. Numerical number 1. We measured we measured the period of we measured the period of we measured the period of oscillations we measured the period of oscillations of a simple pendulum in successive measurements in successive measurements in successive measurements the readings the readings the readings turn out the readings turn out to be the readings turn out to be 2.63 seconds comma 2.56 seconds comma 2.42 seconds comma 2.71 seconds and 2.80 seconds. Full stop. Calculate mean period of oscillations. Calculate mean period of oscillations. Calculate mean period of oscillations, comma, error in measurement, error in measurement, error in measurement, comma, the absolute errors, the absolute errors, comma, relative error, comma, relative error, comma, percentage error, error. Full stop. Now resolution is resolution is 0.01. This is the numerical. Once again, I am repeating the numerical, my dear students. We measured the period of oscillations of a simple pendulum in successive measurements. The readings turned out to be 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds and 2.80 seconds. Calculate mean period of oscillations. Error in measurement. Calculate mean period of oscillations, comma, error in measurement, comma, the absolute errors, comma, relative error, comma, percentage error. This is the given question by the examiner. Now, at first, we have to write what the examiner given. What the examiner given? The examiner given simple pendulum successive measurement. What are the measurements? Successive measurements. Successive measurements. Successive measurement readings. What are that one? 2.63 comma 2.56 comma 2.42 comma 2.71 comma 2.80. How many readings are given by examiner? 1, 2, 3, 4, 5. 5 readings are given. Now go for the point by point. At first what we have to find? At first we have to find the mean. Therefore case number 1. Mean value of the quantity. At first, mean value of the quantity. The mean value of the quantity we can write as A mean. Now, this is siding. So, what is the mean value? A mean is equal to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 whole by 1, 2, 3, 4, 5. The number of readings are 5. As a result, the A mean is equal to how much we got? We got 13.12 whole by 5. That is equal to 2.62 seconds. Okay, now point 1 is over. Now point B. What is point B? Error in measurement. Error in measurement. Error in measurement. The error in measurement we denoted by delta A, delta A, error in measurement. So the error in measurement, how we can determine, that is delta A1, delta A1 is equal to real value, that means A1 minus A mean, A mean. This is the formula. So what are the values we are getting? That is equal to, what is A1? 2.63 minus what is A mean? A mean is equal to 2.62. That is equal to how much? 0.01. Now delta A2 is equal to A2 minus A mean, that is equal to 2.56 minus how much? This is 2.62, that is equal to 0. That is equal to minus 0.06. Now delta A3 is equal to A3 minus A mean, that is equal to how much? 2.42 minus 2.62, that is equal to minus 0.20. Similarly, delta A4 is equal to A4 minus A mean, that is equal to 2.71 minus 2.62, that is equal to 0.09. Now delta A5 is equal to A5 minus A mean, that is equal to 2.80 minus 2.62, that is equal to 0.18. These are error in measurements. Now we are going to derive point number C. What is point number C? Absolute error. Absolute error. The absolute error, how we can define? The mod of error in measurement is called absolute error. That means the mod of absolute error is called error in measurement. That means absolute error is equal, how we can write? Give the mod to that one. That means delta A1 mod, that is equal to how much? Plus 0.01. Similarly, mod delta A2, that is equal to how much? 0.06. Similarly, mod delta A3 is equal to how much? 0.20. Similarly, mod delta A4 is equal to 0.09. Next, mod delta A5 is equal to how much? 0.18. Like that, we at present we sorted out absolute error. Now we are going to derive next absolute mean value or absolute mean error. Now point number D, that is absolute mean error. Absolute mean error. What is absolute mean error? That is delta A mean. What is delta A mean? That is delta A mean. The delta A mean also we derive. This is we write as delta A mean and also delta A mean bar. Okay, so another one also. What is that one? Delta A mod. Delta A mod. These three are nothing but absolute mean error. Therefore, absolute mean error is equal to, how we can write it as, that is called delta A1 mod plus mod delta A2 plus mod delta A3 plus mod delta A4 plus mod delta A5 whole by the number of divisions 5. Therefore, delta A mean is equal to, so what is that values? 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 whole by the number of divisions 5. As a result, we will get 0.11 second or approximately equal to 0.1 second. Now, that means what we understood? We understood that means the period of oscillations, the period of oscillations of simple pendulum is lies between T mean, sorry, A mean and delta A mean. Now, next, relative error E. Relative error the another name is fractional error. Fractional error. The relative error, fractional error. That is the relative error is called how much? 0.1 by, that is 2.6. So how much we got? We got 0.04. Now our next concept is percentage error. Therefore, percentage error. The percentage error is denoted by delta A. Now, the relative error delta A is equal relative error into 100. Therefore, delta A is equal, what is relative error? This one, 0.04 into 100. Therefore, delta A is equal 4%. Like that, we have to solve the any type of the numericals like this. Now I would like to give a small homework. Please try your own. I think you understood how to solve this type of the numericals. Now go for homework. The diameter of a wire the diameter of a wire as measured by a screw gauge measured by a screw gauge was found to be 1.328 comma 1.330 comma 1.325 comma 1.326 comma 1.334 and 1.336 centimeters. Now calculate point number A, mean value of diameter. Mean value of diameter. Point number B, point B, error in measurement. Error in measurement. Error in measurement. Point number C, absolute error. Absolute error. Point number D, absolute mean error, absolute mean error. Now point number E, relative error or fractional error. Fractional error. Point number 5, percentage error. My dear students, once again I am repeating the question. Please observe carefully. The diameter of a wire as measured by a screw gauge was found to be 1.328 centimeters, 1.330 centimeters, 1.325 centimeters, 1.326 centimeters, 1.334 centimeters and 1.336 centimeters. Calculate mean value of diameter, error in measurement, absolute error, absolute mean error, fractional error, percentage error. So this is the numericals. You please do homework and try yourself. Now, glance. Glance. Point number A. Mean value. Mean value. That is A mean. Point number B. Point number B. Error in measurement. Error in measurement. Error in measurement. That is delta A. Next, point number C. Absolute error. Absolute error. That is mod delta A. Next, point number D. Absolute mean error. Absolute mean error. That is delta A mean of mod. Next, E. Dear students, once again, total F points are there. E, relative error. Relative error. That is there is no any term for this one. Next, F, we also write it as relative error delta A mean whole by A mean. Okay, delta A mean by A mean. This one by this one gives relative error. Now finally percentage error. Percentage error is equal relative error into 100 gives percentage error. My dear students, these are the 5 steps we have to solve any numerical. Point number 1, mean value, error in measurement, absolute error, absolute mean error, relative error, percentage error. These 5 points we have to remember. Then we can easy to solve any type of the numericals. I hope you understood the numericals as well as the glance. Thank you very much for watching this video. Thank you.